Hi, everyone. We're going to continue on with Chapter 8 here, Perfect Competition, the first of our 4 market structures. And in this recording, we're going to have a segment on the marginal approach to profit. Now, previously, we've learned about the total approach to profit, which is quite intuitive. It's total revenue minus total cost. That'll give you your profit. And where your total revenue just equals your total cost, that will be a break even. So we're going to expand and go further into something that we rely on quite a bit more in economics, and that's the marginal approach to profit. So here we go, the marginal approach to profit. So it's another approach to profit maximization, and we can just start out and state that a firm maximizes its total profits by producing an output or a quantity where the marginal cost just equals the marginal revenue. And we know from Chapter 6, marginal cost is the incremental cost to produce one more unit of output. So marginal cost is the change in total cost to produce one more unit of output. And just earlier in this chapter, we determined that marginal revenue, well, that was the change in total revenue received from producing and selling one more unit of output. So those two are very similar, but opposite sides of the same coin, so to speak. So here, if marginal revenue, or in other words, if the incremental revenue we receive from selling one more unit of our product is greater than the incremental cost of making that one more unit, why wouldn't we produce more? The marginal revenue we're getting is greater than the marginal cost of producing it. Likewise, if the marginal revenue we get from selling one more unit of product actually turns out to be less than the marginal cost of making that one more unit, we wouldn't produce it. We'd produce less than that if we're looking to maximize profits. And that's the name of the game here. So to maximize total profit, we produce where marginal revenue equals marginal cost. And this is a major, super important golden rule that we will use time and time again in this and all the rest of our chapters. So let's look at this graphically. First, we'll start with the observation, if marginal revenue is greater than marginal cost, you'd want to produce more units. So remember that marginal revenue, we determined, is the price that results from market demand and market supply. So it's the constant price that's dished out, and producers just accept that price. Their decision is, should we produce and how much we should produce. So if the marginal cost is the red line and the price line or the marginal revenue is horizontal, let's look at quantity number 5. At quantity number 5, I'm going to ask myself, should I produce that quantity? And I look up and I see, well, there's my marginal cost, which is somewhere over here. But I go all the way up to my marginal revenue line, or the price I can sell it with, and it's quite a bit higher. So since marginal revenue is quite a bit higher than the incremental cost, I'd like to produce this 5th unit and possibly even more. So let's take a look at potentially the 7th unit. So on the 7th unit, I go up and I see, okay, that's my marginal revenue. That's what I can sell it for. But I notice that my marginal cost, the incremental cost to actually making the 7th unit, is higher. So I'm going to lose money on that unit. So I'd want to produce less. So I'll click ahead on the slide here to make that observation on the text. You produce less. So in the end, you arrive at that same conclusion. You would just go back and forth between producing more than 5, but less than 7. So the only answer is you'd produce 6. And that's exactly where, excuse me, marginal revenue equals marginal cost. So that's our major, super important golden rule for any company for the rest of the chapter. They will always want to produce where marginal revenue equals marginal cost. That will be their profit maximizing quantity, and we'll look at that a little bit further too. Okay, so let's see the same thing on this table here. First, let's try and understand what we're looking at. We've got output or quantity, and they're giving us total cost that rises as output increases. That makes sense. Now, the marginal cost, we know that's the change in total cost due to a change in quantity. So from 30 to 48, the change in output is 1, the change in total cost is 18. From 48 to 58, the change in total cost is 10, the change in output is 1 again. So all I'm doing is showing how we calculate marginal cost all the way down. Marginal cost falls, turns around, and rises. Nothing surprising there. We've already looked at that before. Marginal revenue, well, that is the price. It's the change in total revenue received from selling one more unit of output, but we know that that is actually the price in the perfect competition market structure. And the price is constant. It stays the same at 20. So now what we want to do is ask ourselves, what is the surplus or deficit of the marginal or extra unit? So I look at point number 1, and I say, should I produce output 1? And its marginal cost of production is 18, but the marginal revenue is greater. So in our previous diagram, we said, yeah, we want to produce that because our marginal surplus is $2. Then I look at unit number 2, and I say our marginal cost has fallen to 10. We know our marginal revenue is 20. And that's a positive surplus. Marginal revenue is greater than marginal cost. So we produce that one. We make an extra 10 for it. Then we look at output 3. We say its marginal cost is 2. Its marginal revenue is 20. Since MR is greater than MC by 18, we go, wow, yeah, we're going to produce that one. Then we look at the 4th unit. Marginal cost is 3. Marginal revenue is 20. So the marginal surplus is 17. Yeah, we're going to produce that one. Look at the 5th unit. Marginal cost of that one is 7. Marginal revenue is 20. The difference is a plus or a surplus of 13. Yeah, we're going to produce that unit. And then we look at the 6th unit. We see its marginal cost is 20. And that just equals the marginal revenue of 20. So the surplus is 0. But let's keep looking. What about the 7th unit? Now its marginal cost is 30 for that 7th unit, but we can only get the price of 20. So the marginal surplus turns into a marginal deficit, and we don't want to produce that unit. Then we look at unit number 8. We see its marginal cost is 40. The marginal revenue or the price is 20. So that's a further even bigger deficit on that 8 unit of minus 20. So we wouldn't want to produce that one. And then we look at the 9th unit, see its marginal cost is totally risen to 60. Very expensive to produce that 9th unit, but we still can only sell it for 20. So the marginal deficit of 40 minus 40, we don't want to produce. So we would want to produce all the way up to where marginal cost just equals marginal revenue, which we showed on the graph. That gives us a total profit of 30. That's our profit maximizing output of 30. Let's take a look. If we add up, if we sum these marginal surplus deficits, we'll get total profit. So we start out at an output of 0, total cost of 30. We've got a loss of minus 30. That's from fixed costs. The next unit gives me plus 2. So now we've got a loss of only 20. The next unit gives me plus 10. So now we've got a loss of only 18. The next unit gives me plus 18. So now we've got a loss of 0. That's a break-even quantity. We're breaking even right there. Now, but we keep going. So the next unit gives us a plus 17. The next unit gives plus 13. So now we're at plus 30. The next unit gives 0. And that's our maximum profit right here. We always pick the second one. And then we keep going. And this would lose some, brings us down to 20, but still positive. Lose more, that brings us down to 0. That's another break-even point. And then, of course, if we keep going, we just get into negative profits, which we wouldn't want to do. So on this slide, the most important one is the profit maximizing output of 6 is where marginal cost of 20 equals marginal revenue of 20. And we have two break-even quantities where our profit is 0 here. That's at an output of 3, and another break-even quantity where our profit is 0 here, and that's an output of 8. So we're going to move on to the next slide and see these points without all the red ink on them. So here it is, and what we want to notice is the profit maximizing point is right there. It's right where we're at our maximum profit, pick the second point. It's where our marginal surplus or deficit is 0. But what you really want to notice is that it's exactly where our marginal cost equals marginal revenue. That's our profit maximizing quantity of 6. Now, we don't know whether we're making profit or losses here. It's just our profit maximizing quantity of 6. And then it takes us over here where we actually look at this is showing us we are making profit. But marginal revenue equal marginal cost will always be the best quantity to go to no matter what. Then I can just look a little further and say, well, that's a 0. Total profit loss is 0. So that's a break even output like we just showed. I'll just put a BE for break even quantity. And there's another 0. So that's another break even level of output or break even quantity of 8. So we're seeing some pretty key things on this particular table of numbers as well as what we saw on the graph. Now, before I go to the next slide, which shows a graph and pulls out this quantity of 6, let me reiterate that we want to find a quantity where marginal revenue equals marginal cost. That's what we want to do. We find the quantity of profit maximization, where marginal revenue equals marginal cost. That'll give us the best quantity to produce. And in this particular slide, it shows that profit is 30. And we got that from adding up the marginal surplus, positive 2 plus positive 10 plus 18 plus 17 plus 13, and it gave us our profit maximum where marginal cost equaled marginal revenue. So here's the marginal cost, marginal revenue graph that takes out and specifically illustrates the quantity of 6. From the previous table where we saw marginal cost right here equals marginal revenue right here. So that's where the marginal surplus deficit is 0. It's the maximum profit we can make. And they show that when we summed up the marginal surplus or deficit, we got that profit of 30. Here's the graph where our marginal revenue and price line is horizontal at $20. We determined that was the equilibrium price from the market. So that's the price that the individual producers face. And their only decision is how much are they going to produce? And that decision is determined where marginal cost equals marginal revenue. They find the quantity to produce where marginal cost equals marginal revenue. And that's right where the lines cross. And that profit maximizing quantity, I'll just write it like this, quantity profit maximum is 6. So we can see that on the table. And again, we saw that on this graph. So we're going to take a look a little further at seeing whether a firm is different way to look at whether a firm is making profit or loss and whether they should shut down or keep producing. So a firm can be in a position of having a profit, a loss, and it may be in a position where it should shut down temporarily. So there's a thing called a shutdown price for the firm. So once again, a firm can be facing a profit. So that's a good thing. It means that the price they're making is above all their average total costs. So per unit. So they're making a profit. It can be breaking even, which means their price is just covering their average total costs. So they're, breaking even. We call it making a normal economic profit. Or it could be facing a loss. And in one situation, it might want to continue to produce even though it's making a loss. And we're going to take a look at that because that seems to be an unusual thing. But in the short run, it may be smarter for them to continue to produce even though they're making a loss, than to temporarily shut down. And in some cases, when they're making a loss, it might make more sense to temporarily shut down. So we're going to explore these possibilities here. Now, they need to make these different decisions, and they're using different cost curves to make those decisions. So there's 3 different decisions they have to make, and there's different cost curves they use to make those decisions. And firstly, the average variable cost covers the variable costs of production. So if I'm producing something, I'm going to incur variable costs, average variable costs. If the price I'm selling the product at doesn't even cover my average variable costs, then I should shut down. But if the price is higher or covering my average variable costs, then I'll want to continue to produce, even if I'm making a loss, believe it or not. Well, we use the marginal cost curve. We looked at that one earlier to decide the best output, decide the most profitable quantity to produce. We find where marginal cost equals marginal revenue. So we use the marginal cost curve for that. And then we use the average cost or the average total cost curve to determine whether or not we're actually making a profit or loss. So these concepts here might blur a little bit, and the use of the different curves might blur a little bit as we go figure out how this all works. But this slide has super important and useful information to carry us through the rest of the options in this chapter. So let's take another look at this in a bit more detail. It's worth it to note that the marginal revenue is the price. So when we decide whether the firm should produce or shut down, we compare the price, or the marginal revenue, versus the average variable cost. And if that price is less than the average variable cost, or the marginal revenue is less than the average variable cost, we'll decide to shut down. And then here, it's the same thing. We compare price to marginal cost, and where price is equal to marginal cost, or what is the same thing, where marginal revenue is equal to marginal cost in this particular model, that's the best quantity to produce. And then to determine the level of profit or loss, we compare price again, but this time it's compared to the average total cost, right? And we know that price is marginal revenue in this particular model. So that'll be how we would determine how much profit or loss is being made. So we're going to deal with this slide in 3 tranches. First, up in the top left corner, if you recall, total profit, or T little pi, total profit is just total revenue minus total cost. So we can rearrange this. We know that total revenue, well, that's the price of something times the quantity sold, minus total cost. That's still total profit. And further, if we break down total cost, well, that we know from its formula, go back and look at chapter 6, well, that's average total cost times quantity. And we have price times quantity here. So that's also total profit, this formula. Now we understand that in this model, price is average revenue, is marginal revenue. So up here where I had price, I substitute in average revenue, and then I go average revenue minus average total cost, all times quantity is also total profit. So that's where we're going to pick this one off. We're going to start by taking our price line, or our $20 line here. You can see I'm drawing green line right over top. That's our marginal revenue, or price, or average revenue. Now our profit maximizing condition is that we find where marginal revenue equals marginal cost. So here's marginal revenue, here's marginal cost, and that's the optimal point right there. All right, well, what did we want to find? Well, we wanted to find 6, our profit maximizing output. So I'm just going to write Q profit max is right there. That's 6. So once we find that, we pause and say, okay, so what? Am I making any profit or not? Now I look down here and I can say, well, I can calculate average profit. That's my average revenue minus average cost. That must make good sense. That's right up here, average revenue minus average cost. Here I've got average total cost, but it's really average total costs. So at this output of 6, my average revenue up here is 20. So I put in 20. All right, what's my average cost? A little bit trickier, but not so much. I just go up to my average cost line right there, and I come across, and my average cost is 15. So I've got 20 minus 15 is 5. Well, I want to know my total profit really. So that's just got to be my average profit times quantity. So that's a dollar figure of $5 on average times 6 units. So my total profit is $30. And if you remember, that's what we got last time. So they're basically showing that and wording it right here, knowing that maximum profit is where marginal revenue equals marginal cost. We found that. It gives 6 units of output at a price of 20, which we know is average revenue. So basically, I can use this up here. I'll underline it, average revenue minus average total cost, or 20 minus 15, times the quantity of 6 equals 30 is the profit I see on that particular diagram. So that's how you learn and look at the diagram and how to calculate the profit. And if you see this, the profit is actually all of this green or all of this blue area in here. I'm not going to scribble it in. It just makes a mess. But really, it's the width of this, which is 6 units, times the height of this, which is 5 units. So it's just the area of a rectangle. Width times height. Again, the height is 5 units, 20 minus 15, and the width is 6 units. So our profit is 30. Now we're going to look at the break-even points. Okay, we can find some break-even outputs on this as well. And if you think about it, break-even simply is where we previously determined, I'll just write break-even, we previously determined that's where the total revenue just equaled the total cost. So total revenue minus total cost is 0. But we know just using basic math, that must mean that average total revenue minus average total cost equals 0 as well. Or we can just look for a point where average revenue equals average total cost. That's going to be a break-even point. So all I now have to do is come along and say, well, where's my average revenue? There it is. Straight across, right? Because we said price equals average revenue equals marginal revenue. So now I'm focusing on average revenue, and I just need to figure out where does average revenue equal average total cost? Well, here's my average cost line right here, the red one. That's where average revenue crosses. So that means I come down here, and this quantity is a quantity break even because average revenue equals average cost there. So we're breaking even. Well, there's another spot it crosses right there. So if I come down from there and find this, well, I know that's another break-even quantity. Why? Because average revenue equals average cost. And if you go back and look at our total revenue, total cost tables, previous tables, you'll find out that quantities 3 and quantities 8 are indeed break-even quantities. Only now we can see it using average revenue and average cost on this particular graph. Okay, so we just finished showing profit maximizing point and showing on a graph how to identify and see that profit. We looked and compared price to average cost, multiplied it by quantity, and we got the level of profit. Okay, so what about if there's a loss? Would a firm be willing to produce at a loss? And the answer to that is a little confusing to understand because they're making a loss, but they're covering some of their fixed costs. So remember, if they've got fixed costs of rent or insurance, if when the grand scheme all happens and the market shakes out and they see that the price they're getting is showing that they're making a loss, as long as they're still covering and paying for some of their fixed costs, they're actually going to want to continue to produce even though they're making a loss. Because if they were to shut down, then not only would they be losing they'd also still have to pay all of their fixed costs because we're assuming they stay in business. It's like a restaurant just temporarily closing. So this one's tricky to see through. Read definitely in the text on this one as well as this video. But would they be willing to produce at a loss? And the answer is yes, if the losses from actual production are less than total fixed costs. They will continue to produce. So what that means is if they were to shut down, then they have to pay all their total fixed costs. That's a big loss. Remember, they still stay in business. They just shut down. So they got to pay their rent and insurance. That's a big loss. So they can produce and sell product. And if they're selling the product and it's helping to pay for some of those fixed costs, then they'll continue to produce, even though they're making a loss. So when is the answer no? Would a firm willingly produce at a loss? And the answer is no, if the losses from production are more than their total fixed costs. The firm should not continue to produce. So what this is saying is, okay, we're producing, and not only are we losing our fixed costs, we're losing more than our fixed costs. That means the price that I'm receiving is not even helping to cover our fixed costs, but also it's not even helping to cover our variable costs. So if the losses from production are actually more than your total fixed costs are, then you shouldn't produce at all and you should shut down. Now, both of these are mouthfuls and they're difficult to see first time through, but make sure you do and can identify situations where they'll continue to produce, even though they're making a loss, and where they should actually not continue to produce when they're making a loss. And it all depends on whether by producing, they're still covering some of their fixed costs or not. And we're going to look at that in a graph after we determine what the heck a shutdown price is. So shutdown, when would a firm shut down? Well, the aim of a firm or the goal of a firm must always be able to cover its variable costs at least. So variable costs are incurred in our models by hiring workers. It's the labor that varies. So you want to make sure you can at least pay your labor costs. And if you can't pay your labor costs, then you should shut down. So labor costs are average variable costs. We want to make sure that the price we're getting for our product is greater than our average variable cost. The price must cover our average variable cost. So if it's greater than our average variable cost, we'll continue to produce because we're selling our products and we're able to pay all our wages, which are variable costs. But as soon as that price hits average variable cost, that's what we call a shutdown price. Then we have to make a decision. We're just covering our salaries by selling our product. So, okay, we can stay in business. But if the price is just even slightly below our average variable costs, that's when we go, uh-oh, we better shut down because we can't even cover our salaries, let alone our fixed costs, but we can't even cover our salaries. So we determine then we're going to shut down at that point. When price is equal to average variable cost, it's called our shutdown price. When price falls below it, even by 1 penny, that's when we would shut down. So to fill this in, to have the big picture here, the shutdown price is where the price actually just hits the average variable cost. So if it's the same as the average variable cost, it's called the shutdown price. You may not shut down there because you're still covering your salaries, but you're very careful. As soon as the price falls a little bit, you definitely shut down. So let's take a look at a couple of graphs showing this stuff. So the first graph on your left, we've already looked at. So we'll look at that again quickly here, but I want to draw your attention to the bottom left of the screen where I've written the golden rules. And the first one is you first find the profit maximizing quantity down here where marginal revenue equals marginal cost. Now keep in mind, marginal revenue is price. So you find that profit maximizing quantity where marginal revenue equals marginal cost. And then the second thing is you find out, is price greater than average variable cost? And if it is, then you continue to produce. You don't shut down if price is covering your average variable cost. And then the third thing is you compare your average revenue, which is also the same as the price, to your average total cost to calculate the profit or loss. So let's take a look up top here, where the first rule is you find out where marginal revenue equals marginal cost, and that's right there. You go down and you find your profit maximizing quantity that you think you might want to produce of 6. But then step 2 is you got to check and make sure that your price is covering your variable costs. So here the price is way up here. Remember, that's also price. And it's greater than my average variable cost, which is way down here. That's at this quantity. So then you go ahead and you produce. You don't shut down. And then what you do is you compare average revenue to average total cost to calculate the profit or loss. That's point number 3 down here at the bottom. So at this quantity, my average total cost is right there. Here's my average cost curve. And my average revenue is up here. So because my average revenue is greater than my average total cost, there is profit. And the blue area is the amount of profit. So my profit would be my average revenue minus my average total cost times quantity. And you got to put these in brackets. So that's the blue area. Okay, so let's go on to the second slide. So we follow the exact same procedure. I find the quantity profit maximum where marginal revenue equals marginal cost. So if this is now the price of 10, which remember is marginal revenue and average revenue, I find out where that equals marginal cost right there, because there's my marginal cost. And I find my profit maximizing quantity, let's just say it's 5. So that's the quantity I'm thinking I would want to produce. But then step 2 is I got to check if that's greater than average variable costs. Because remember, if it's not, then you're going to shut down. So here I look at this quantity, my price is greater than average variable cost. There's my average variable cost, pointing at it. My price is higher than that. So phew, we don't shut down, right? We're not losing that much. We're still covering some of our fixed costs. And then the thing that we want to do finally is calculate profit. So we compare average revenue to average total cost to calculate profit. So we'd go like this, and I'd say at this quantity, my average revenue is right here, the lower amount, the price of 10, and my average cost is higher. So sadly, I'm making a loss. That's this blue area. So I'd calculate it. There's my average revenue minus my average total cost. You'd take the numbers off the graph times quantity, and it would be negative. So we'd see a loss. But the point is that the price is still covering some of our variable costs, all of our variable costs, and some of our fixed costs, actually. So we lose less by continue to produce. If we were to shut down, we'd lose all of our fixed costs because we have to pay them every month. But if we produce, at least we're covering some of them. That's what this is showing. And granted, it's hard to see. So make sure you go over this a few times or look at the text. Okay, so let's look at this third diagram. And we start with the same old rules. We find where the quantity profit maximum point would be, where marginal revenue equals marginal cost. So here's our marginal revenue, and there's our marginal cost. Those two equal right there. So we determine that the best quantity to produce would be 5 if we're going to produce at all. To make the decision if we were going to produce at all, we find out if price is greater than average variable cost, then we produce. Well, even if it's equal to average variable cost, we might still produce because we're covering our variable costs, we're covering our salaries. So we look at this and we notice that the price is equal to average variable cost right here. There's my average variable cost. There's my price. They're the same at this quantity. So that's called our shutdown price, We may not shut down because we are covering the variable costs. We're paying the salaries of all the workers. But if price were to fall 1 penny below this amount, then we wouldn't be covering our variable costs. We couldn't pay our salaries and we should shut down. So that minimum average variable cost, that price is called the shutdown price. Now, let's figure out what our profits would actually be. And we said profit is equal to average revenue minus average total cost, all times quantity. I'll just use that quantity right there if you don't mind. So my average revenue is right here, comes off the green line, and my average cost is way up here. So average revenue minus average cost is negative. We would show a loss of this whole blue amount. And it's bigger than this loss, but it's kind of put us in a decision, do we shut down or not? And we are covering our variable costs, so we probably won't shut down, but it's called the shutdown price. That's the minimum of average variable costs there. Okay, so let's recap all that stuff we did on the graphs and the process, particularly the red that I wrote on the previous page that showed the first step, second step, and third step. So they outline it here nicely for us. First, you start and say, is price equal to marginal cost? And if it's not, then you got to keep going till you find where price is equal to marginal cost. And remember, price is actually marginal revenue in this case. But if price is equal to marginal cost, then you're going, great, let's check something else. We know we've got the right quantity because price is equal to marginal cost there. So now we want to say, are we making profits or not? Is price greater than average total cost? Or again, is average revenue greater than average total cost? Because these are the same. If it is true, then we're making a profit and we stay at the current output and continue to produce. If price is not greater than average total cost, then we're making a loss. That's okay, because we may still want to continue to produce. If price is covering our variable costs, in other words, we're paying our salaries, great. We keep going and we stay at the current output. Now we're still making a loss, but we're making less of a loss than if we were to shut down because the price is covering our variable costs and some of our fixed costs. However, if price is not covering our variable costs, then that's when we would shut down and just pay our fixed costs, which would be less of a loss than if we continued to produce where price was below variable cost. Hopefully that one makes sense. Go through that again until you see it and be able to see it on the graphs from the previous page as well. All right, let's do this example. So basically, we're still going to follow those 3 steps that we've outlined. It shows a graph here for a perfectly competitive firm. And in the industry, so way over here, there'd be a demand curve, a supply curve, and the price that would come out would be $120. So the firm then accepts that $120. So if the price is $120, what's the optimal output? Well, that's no problem. We just go to a price of $120 and we draw the price straight across. Remember, that's marginal revenue, average revenue, and price. MR, AR, and of course, it's the price. Okay, so then the next step is we find where marginal revenue equals marginal cost, and that's right there. So our optimum quantity, our best quantity, our profit maximizing quantity is 70. Great. Now, do we continue to produce? And the answer is yes, because at this quantity, there's average variable cost, and my price is greater than average variable cost. So I'm going to continue to produce. I'm covering my variable costs, my salaries, and more. Okay, so we found the optimum output. Let's find a profit or loss. Well, I know the price or the average revenue. Just at 70, I have to go all the way up to here and come across to find my average total cost. ATC is 140. So I know that the profit here is my price, which is 120, minus my average total cost, which is 140, times the quantity, which is 70. So 120 minus 140, unfortunately, is negative 20. And negative 20 times 70, unfortunately, shows that we've got a loss. So let's click the slide and see their calculations. At 120, optimum output is 70, and there's a loss, simply because price or average revenue is below the average cost. So this would work out to be 20, oops, let me grab this a bit better, minus 20 times 70, so minus 1,400 would be the loss. And it would be this rectangle area in here. But keep in mind that because the price is greater than the average variable cost, price is up here, we choose to produce even though we're making a loss, because our losses are less than if we shut down and we'd have to lose all of our fixed costs because we'd still keep paying them. Okay, so I'm going to clear this. And the next question is, what's the shutdown price? Well, the price is the shutdown price is the lowest variable cost we could sustain. So in general, that shutdown price is the very bottom of the variable cost right there. So if I want to find out that shutdown price, it's 100, the minimum of the average variable cost. That's when the price could not fall any lower because we'd have to shut down. We'd be losing too much at that point. So let's just go back to an empty slide here and try something different. What if the price is 160? Let's just do our own analysis. What if price is 160? What quantity? Well, the quantity profit max, the first step is we always just take this price of 160 and go across. And we find out, I drew it a little off there, we find out where price or marginal revenue, it's the same thing, is equal to marginal cost right there. So this is the optimal quantity. The quantity profit max is 90. Okay, so from here, I know that that price is way above average variable cost. So we definitely do not shut down because it's way above average variable cost. And there's my average cost. So my price is even above average cost. So I know I'm going to make a profit. What is my profit? Well, average revenue minus average total cost, all times quantity. What's my average revenue? Well, that's the same as the price. So I go up here and there's my price of 160. I'll even put that on here. This is also average revenue, the red line, equals marginal revenue. So my price is 160. My average total cost is right around here, which I'm guessing is about, let's just say it's 145. All right, so I'm guessing at that. My price is 160, 145 is my average cost at this quantity. So I multiply it all by 90. So 160 minus 45 is 15 times 90. And I'll let you do the math to show the extra profit that I'm making or the profit that I'm making when the price is 160 and the associated quantity, the optimal quantity, is 90. So that's an example that we could do. We just made it up on our own, and I could make many, many examples. What about this one here? If I clear everything here and say, what about if the price is 95? My profit maximizing quantity. Well, the first step is I take that price of 95, which is about there, and I draw it straight across. And that's my marginal revenue, average revenue, its price as well, MR, AR. First step is find where marginal revenue equals marginal cost. Well, that's right there. So the optimal quantity should be 60. But, and it's a big but, price is less than average variable cost. Right? Price is here. Average variable cost is higher. So what do? You shut down. What quantity do you produce? Quantity equals 0. Not 60. We determine that you shut down. So the quantity that you're going to produce is 0 if the price is 95, or the quantity this company is going to produce is 0 if the price is 95. So keeping all these different prices we looked at and how much we produced, you might be thinking of a supply curve, because the companies are only going to produce when the price is above that average variable cost. So let's take a look at that and show just how we determine a company's supply curve. So here it is, the firm's supply curve and the industry supply curve. So for the particular firm, we just looked at that. If you go back the slide, at a price of 45, we would go across and we'd see that marginal cost is there. So the producers are willing to produce 7. This producer is. If the price dropped to 35, we go across to marginal cost, come down, well, they'd be willing to make 6. If the price went to 25, they go across, hit marginal cost, and they now know that that price is below average cost. So they're making a loss, but it's above average variable cost. So they don't shut down yet. So they'd produce 5. Then if the price got down to 20, we come across and right there, we'd produce 4. But if the price falls below 20, we don't produce any, because price gets below average variable cost. So the only amount that we'd produce would be this green curve here, this green part of the marginal curve, the solid fat part of the marginal curve. So that's really the individual firm's supply curve. So below average variable cost, the firm would produce 0. That's if the price was below 20. But otherwise, the firm's supply curve is really the portion of the marginal cost curve that's above average variable cost. So it's this solid, thick green part. It's above the average variable cost. So that's the individual firm's supply curve. And we all know that the industry's supply curve is just going to be the sum of adding up all the individual supply curves. So we add up all the supplies of each individual producer to get the whole industry supply curve. So here's the marginal cost, or the firm's supply curve. For one firm, it's its marginal cost curve. If we just added them all up, we would get the industry supply curve. So it's the total of all the firms' marginal cost curves. That's the industry supply curve. They also threw the demand curve on here, so we can find an equilibrium industry quantity and an equilibrium industry price. And that's the price that the individual firm faces. But the point of this slide is to say we add up all the firm's supply curves, which are really their marginal cost curves, and that gives us the industry supply curve. So that brings us full circle. We started with the supply curve a couple of chapters ago, and now we know what makes up that particular supply curve. It's all the individual firms' marginal cost curves. All right, so that brings us to the end. Not at the end of the chapter by any means, but the end of the marginal approach to profit. So please go over this again carefully and follow the slides or read in your text to understand it. It's a key component of this particular chapter, and it helps us understand and relate to all the other chapters, because all of the other market structures are compared to perfect competition. So I hope you enjoyed it. Talk to you soon.